this time. So guys, you are recorded. Don't worry, it doesn't hurt. Well, and I mean, I should also start sharing. So basically, I will start a bit slower so that I explain the, well, natural causes for all this is when I started to work with Practic solver, which I developed. I faced a serious problem how to explain to people that Practic is a reliable tool. So I prepared something which I called FATLIM database, and this is simply pre-programmed database of experimental data, where when I show all experiments, I simply put different load cases. Each row here is a load case with a given setup of tangent, torsion, pressurizing, with description of individual load channels. This is first load channel, second load channel, shear load channel. These are the phase shifts between individual channels. Yeah, because of this, if there are three load channels, it means usually there are three independent actuators or whatever else, pressure valves or whatever else, which induces loading in a separate modes on specimen. And there is also a period because of it can differ. So this all was given into the database, and by that I could show that I have some aggregated group of data which can be in some way analyzed. I put there also results of specific calculation methods. So then I was able to show also what is the relative error in estimation of fatigue strength. So these are these numbers. So anybody could go through that, check the experimental data, verify if I input them right into the database, and to then get the results. What was also possible, this whole task, all those experiments were input into Practic solver as one task only, though they are for different materials, different load cases, and so on. So there was prepared some kind of aggregated experimental input, and on all of these experiments, one calculation or several calculations with all these methods could be done. So anybody could check the content here, establish the fatigue analysis in Practic, check that it really corresponds to what is written here, and run the analysis to check that everything works well. So I was satisfied. But already in that moment, I started to plan because we had other. This one was just for fatigue limit estimation, and we wanted to dive also into finite life estimation. I wanted to extend the database. Yeah. I've got some funds for that, and we started to develop what is now called FinLiv database, which I will show you today. And there we wanted to definitely go into experiments with finite life. And we knew from this first my database that the description of there was quite insufficient. I could describe what was the load case, but there was no hint about, say, dimensions of the specimens. For multi-axial fatigue, it's quite important if this is a hollow specimen or this is a full bar specimen. So I started to develop an interface for, say, aggregating the experimental data, and the expectation what it should be capable of databasing, putting into tables, was that it must work with the multi-axial fatigue cases. That means multiple load channels should be input. what I found out, we should also deal in some way with different materials and their description. And these materials and their description could be modified due to added thermomechanical treatment, either on the setup of the semi-product, because of it can be delivered, for example, in quenched and temper condition, and then in some way turned and then modified, for example, by normalizing or whatever else, or done after the specimens are produced. Yeah, so two different levels of thermomechanical treatment. We knew that we have to deal with different shape of specimens. We wanted not to deal just with SM curves, but also with a strain life approach, that means Manson-Coffin curves, and ideally also with static tests. And what else? To describe individual data points on the curve, and so on and so on. So what you see here is the final interface for digesting the experimental data. In that moment, I divided the question to two tasks. One was how to input and manipulate data, which I was used to work with Excel and I loved it. And the other is how to present the data to, say, cooperating institutions, members of the project, or later on maybe to some customers, but also how to search within them. So we split that, and as regards the aggregation of data, this Excel workflow was developed. And the second part was from this Excel workbook, we generated a comma-separated worksheet. That means a single text file for each aggregated unit, which was uploaded into a website which contains all the database structure. There in the database, it was possible to do the search, to present the data, to show them, to access them in some way with different roles and so on. Unfortunately, this project ended with a big bang in 2015 because of I got into disputes with, say, leaders of my faculty, and the project was frozen, which means it got dead. Yeah. So we had to abandon it in some way. We transformed the input into something a bit else, renamed also the database to Matic. Yeah. But otherwise, this Excel sheet was very, very similar as it was previously. This, however, means that this website representation of this content was completely lost. Because of time by time it got, say, obsolete. We didn't manage it anymore. And at last, we also abandoned the website dedicated to that. We started to build a new version, which I will show later on again. But there it didn't end to any end because of, well, simply I started to be more focused on Faber project, and believe that very soon we will get funds for that. And in that moment, this, say, one institution work has very little sense because of the future members for sure will like to modify the content and so on. So I got a bit distracted. And from 2021 or something like that, there was no substantial development. So currently we have no website representation because of, I believed that we can develop a better one. However, what is now here is quite interesting for us because of it shows us, say, some kinds of manipulation of data, how to work with them, and what is missing here. So I will start to present how it works in this version, which can be also shared with you. First of all, what you see here is, say, user's interface for uploading existing data, which you in some way get from papers, into a comma-separated variable sheet. Yeah, that means to something which can be digested by some other software. That means website. We did also here, for example, automatic preparation of notch specimens in APDL for ANSYS. We prepared here some automated input for practice solver, so this task could generate separate tasks for beam crime practice and so on. These individual sheets are, every time you save it, are projected into those individual sheets. Basically, these are the website representations of this CSV file about which I talked previously. So whatever I see here has a projection here. Which means here in this file, I'm gathering only information which is in this moment in some way under development in the process. Yeah. But anyway, anytime I decide, okay, I have too many sheets here, I can simply generate here through backup button. I can simply push it into a CSV representation of each individual files and get them for later use. And if necessary, I can again import it either from CSV file or later on I will show you also from XLS file from Excel representation. So this interface should be capable to generate any of these sheets so that it can be then uploaded for future use in some way. Yeah. In this sheet, what we see is the first here is the interface. That means here I have some selection combo boxes and list boxes and buttons functional and so on, which allow me to input the content. So what I am basically saying here, there are several parts. The first one, these items are representing what regards the semi-product. Yeah. So if I have specimens prepared from a single semi-product, I will make a unique mark for the set. And it also is related to some specific paper. In the moment we build that, we prepare the website representation not only for fatigue data, but we prepared a separate representation for material database, which is related here by ID number. And we prepared a separate database for references because we wanted to use it in a similar way as it is now in Zotero, where we expect that we can share the information about the quality of the papers, their allocation to specific working groups, specific tasks of our project. So we built also a database of references with categorizing and classification of different papers, which cost us a lot of time. And unfortunately, now I see that it's not that useful anymore because of it's just unnecessary. With Zotero, it's good enough. But here, what I'm doing is that I'm giving every time a hint for which material this dataset is prepared and for which paper the data are input. There are some comments which are related again to the semi-product or all the test series. Test series is the series of data generated for the same semi-product. And for this semi-product, I'm also discussing the thermomechanical treatment. Here it is written material, but I mean the semi-product of the same input, the same lot, the same batch. Yeah. And here I can select the different types of thermomechanical treatment. Based on that, if I select induction hardening, I will get the information which environment can be there for this type of treatment. and based on that, I'm getting the salmon color background for expressing what is necessary, and also the commentary modifies to let me know what's necessary input for this type of treatment. So once I have this description of the thermomechanical treatment for the semi-product, I can proceed to individual curves. Yeah, if I show it here, I get a version of the software, mark of the semi-product plot. Yeah, ID reference to individual papers, because of later on we found out that some data sets are spread over, for example, 5 papers. So we had to differentiate individual curves. And then we have the ID of material, its name, plus comments, and the treatment dedicated for this type of material. So if I make now a save, because if I'm changing this to induction hardening, I put there some commentary and temperature, let's say, what is this? This is core cast iron. I have to say that I have no idea, but let's say 800 degrees Celsius and time 30 minutes, for example. Yeah, so when I push save now, it projects. Oh, it should project. I made a little change here because if I wanted to preserve this data sheet and it's not projected correctly. So sorry for that. And let's try once more. You know, well, better not to touch it that much, because if I made some unstable error there, or some modification which triggers these errors. I will try simply to go to another test set. Here it works. Well, that doesn't matter that much, yeah. So this is for treatment of the semi-product. Then we proceed with the description of fatigue curves. Yeah, I will maybe switch to some other file which I have here. Also, I will rename it. And better start it again. So apparently I made some error there. Here it works. Okay. So here you see, for example, that the quenching operation is already available here. This is another set. Yeah, by selecting or in this list box, I can check whatever is here in these individual sheets to get it there. So I switch to another case, and you see the content. All of the specimens here, no, they are not. So I can select, for example, a curve number 4, and you see that there was some update. Yeah, curve number 4 in this moment is of the SN curve type. You see that it can be related also to Menzen-Coffin curve, static test, or cyclic stress strain curve. Yeah. What I have to say, in this version of FinLiv, we mostly deal only with SN curves, and I do not say that all the other content is working correctly because of its, well, say, nearly 10 years when the project was finished. Yeah, so I do not remember to which phase we got there. So we have description of the curve, which type of it is, what is its number, and what is very important, we are here gathering information, what is the type of the input. Yeah, and what you see here, we have either hand-drawn graphs for very old reports from, say, before the Second World War, graphs generated by computers, which are for sure a bit better than something drawn by hand. Then we have raw data in numbers, which has the best quality. And in some cases, we allow also just regression outputs, but, well, I do not like this type of output. Yeah. Based on this, we were preparing some kind of description of uncertainties related to acquisited data quality. Yeah. Then for each curve, I define what is the type of specimen. And you see here is predefined, oh, sorry, here's a predefined list of typical types of specimens which can be used for fatigue analysis. Because of if you check that in reality, if this is not a very special case of, so for example, contact fatigue or whatever else, or very, say industrial cases, the number of configurations is very slow. This is the reason why we believed that we can proceed to APDL with generating automatically based on just geometrical configuration finite element models, which could be quickly prepared and processed. And once we get this type of categorization of individual parameters of the specimen, we can proceed by filling it in. Again, you see that the hints here in the right corner are updated based on the configuration of the specimen. Then we proceed to further questions. The question is, what is the orientation of the specimen to the semi-product? Because of if I have a sheet or plate semi-product, I can have different directions. Yeah. If I have a bar specimen or bar semi-product, again, I can produce specimens with different orientation to the semi-product axis. And it matters as regards the output of fatigue results. And then there is an important question to which stresses is related the information about loading. If these are net or gross nominal stresses or potentially whatever else, but usually these are nominal stresses that we are getting. So here is just two cases, net section or gross section stress, which is important for any analysis of notched components. Then there is an informative section concerning KT's, stress concentration factors, and again comment, which is in this moment already related just to this curve number 4. If I proceed next, there is a second section of the thermomechanical treatment, this type for this specimen, not for this because of the curve is composed of many specimens, but for specimens which are related to this specific SN curve, number 4. So I see here that it was turned with very little information, even no commentary here. which is basically a mistake because we know at least what was the final roughness. Yeah. So I could input it here. And then comes the next section, which is focusing on the information about the loading. In this case, we had very simple loading, just push-pull loading, tension compression. But if I switch, for example, to another curve here, number 6, it will be still very simple, but we will find out that in this moment, the loading is wrongly written. There is a mistake. It should not be tension, it should be plane bending. So apparently when uploading the data made an error in all cases. So I can nearly immediately start to repair it because of what I know is that any change here is projecting after pushing the save button to this TUC file. And what I know also is that for simplification, we prepared in that way that here in column B, we see what is the, say, acronym describing which component is described here. And here in LC mode, I see that there is no load case, tension compression, plane bending, rotating bending. So when I was preparing this file, I forgot about that to make it correctly. And if I check LC mode parameter here in the sheet, I can dive immediately there and push there that the information was such that oh, I have to check it. Tension compression, no load is case 0, this one is case 1, plane bending 2, 3, 4, 5, 6. And there it is in such a way that here I have tension, here I have, forgot that, plane bending is second, okay, and this is 6. Here is torsion, here is plane bending, and the same pattern is in all 3 curves. So when I push now reload, first save, then reload, then I should see for curve number 5, oh, something got wrong. And now when I continue to curve number 6, this should be already plane bending case. And this is plane bending. So it started to work. Sorry, because of the more you are used to work with that, usually you do not use this interface and you are directly inputting all inputs into this sheet because of it's much simpler, quicker. So for some time I didn't use this and I was not aware what is the sequence of steps to do to modify something. So that means in this case, I have a plane bending case with a harmonic constant amplitude. You see which types of loadings are allowed. That means this is harmonic constant amplitude. I can add additional load channel with, for example, the same plane bending, but with constant load to prescribe it here at, for example, 100 megapascal or something like that, and proceed with other cases as well. If I check the load path, what it does, it shows me what are the load levels between individual data points, or not data points, but individual channels. What it is, how it is composed in multi-axle fatigue, it's usually that you have something which I call here master channel, something which is shown on in the SN curve, and all other load channels are dependent on that. Either they are constant, that for example torsion load channel is at constant shear stress or torsion stress, or they are in some way related by some coefficient to what is happening on the master load channel. So this is accepted here, and basically what I am doing here is that I am saying, okay, to numbers of stresses which I have here for plane bending load channel, I will simply multiply it by 1. But for the plane bending case, I am having a constant value of 100 megapascal in any case, whatever is the load level in the plane bending load channel. What I can do as well is to modify, to make it as a multiple. In this way, I can say that in all cases here, for any stress level on amplitude on plane bending, I will have half that on the constant load, on the mean stress. So in this way, I can superpose both amplitudes and mean values of the load channels, but also different load channels. This could be torque, for example. Yeah. So based on that, I can aggregate all the information. So if I check the load path, it doesn't change that much, only because of this is amplitudes. It is recalculated to 1/2. Yeah, because of, yeah, here you see multiple 1, multiple 0.5. So what I'm getting here, if I have a constant amplitude, first information is about amplitude. This is either a constant value or a multiple of the reference value written later on below. This is the mean value. If I want to not to superpose it to this way, but directly here, yeah, there is information about the frequency and phase shift. Because of all these information, items are very important to correctly set up the multi-axle loading. In addition to mechanical loading, there is also a possibility to input also a thermal load as an additional load channel. So by this, I can prepare whatever I want. Yeah, I can push here again also. Oh, sorry. Push it like it is here. Say there will be 100 megapascal in torque or in shear stress in mean value. Frequency will be the same, or let it be 2 times that. And let's make there a phase shift of 90 degrees. And if I check the load path, it will show me, hopefully, yeah, how it looks. So I have some visual check that I input it correctly. That's about loading for this one SN curve. Then I can modify also the information, what is the end point of the test. And that's very often forgotten in describing the experiment. what was the moment when the test was claimed to be finished. In SN curves, it can be the moment when the both sides of both parts of the specimens are completely separated. It can be a moment when you cannot proceed because of for example, for resonator machines, you can get to a moment when the machine is not able to control the loading because of the crack is so big that it doesn't proceed. It can be a dedicated dimension or length of the crack. It can be decrease in the stiffness of the specimen. It can be whatever else. So here are different variants for this end of the test, plus a parameter which relates to that. Yeah, so in this moment it was chosen that once the frequency decreases by 5% of the original value, which was 133, it should stop the test. And then I have the description of the specimens as they were experimentally tested. Yeah, I have here a mark, which is quite important. Whenever it is there, it's good to have a reference to a specific specimen number. Then there is the stress value, which is used for this setup of individual load channels. Yeah, so this is a reference value with which you are working here, potentially also on mean stresses and so on, and to which number of cycles it led. Yeah, and this is still the end condition. The end was defined here. In many cases, the researchers decide to continue with the test. Okay, they know that, okay, frequency was decreased by 5 Hz, but we wanted the specimens to be completely separated, so we continue. So then we proceed with the number of cycles to break, when the tests were physically really stopped and no way in continuing. So these two numbers can be the same, which is quite often. In some cases, till break can be higher than till end. And there is one special case which is called runout, which means that the test took too much time, that the experimenter decided to stop it because of it led to numbers of cycles which are deemed not of interest anymore, and any continuation asks for a lot of money. So these runouts are till the end, but because of they did not reach the final end, it is here written as interrupted. So these are special specimens, special cases which didn't proceed with the final break, whatever it was. And here I can add a commentary in addition. So when I check it here now in the spreadsheet or in the sheet of the description, I see that here I have the description of the semi-product, and then I continue in a column-based description. So here I have curve number 1, curve number 2, 3, and so on till 9. And then I proceed with the description of the type of the specimen, of the source. In this case, it was all from tables. What is the specimen type? Here, when I understand the logics, I know that these were full bar specimens, and these all were specimens with hollow cross section. So then I have description of individual parameters. Because of this one is full bar, I have only outer diameter, but here I have outer diameter and also inner diameter and some other dimensions. I have here information about orientations, potentially KTs, some comments about the quality of whatever I want to describe for this curve. Here we were doing tests what the change of depth of cut will produce as residual stresses and roughnesses. So those 3 different cases of specimens modified with different depth of cut. Here you see one set of specimens, second set of specimens with different depths of cut during turning, and the last one. So then I proceed to other possible information, and this is the load mode proposed, and description of individual load modes. And then we are getting information about end of the test, plus description of the mark, description of stresses, and so on and so on. To the end of this file, we edit also information which is derived later on. And this is description of chemical composition and if there are any basic material data, plus the information about regression parameters later on. So this is how it is composed here. Yeah? So I have all information saved into those individual sheets. I can work with them. If needed, I can switch between them, check what is the content. Through this interface, I can modify them. But usually, as I told you, I'm usually running it directly here in the sheet because of it's much quicker. Very often, these individual test setups are very similar, and only some parameters plus lifetimes and marks of specimen differ. So I'm basically inheriting the content of the test to next sets, next SN curves. With the form, I can do saving. In this moment, I will return where it was previously. This is curve number 6, which is plane bending. That's correct. But here should be no load. So I will remove it. And in this moment, I can save it again. There are several functional buttons here. First, once I have the datasheet written down, I can export it. This means here backup. This will generate me a CSV file. Technically, it will just take the sheet and convert it into a CSV. If I need it, I can import it later on again back. I can remove the sheet whenever necessary. I mean from the representation here in Excel because of I find out that I have too many too many sheets here, so I decide, oh, I do not want to see it now because of it's a closed task. I can do that manually. I can simply push delete here, remove. But the issue is that the database is not updated. So in that moment, I have to do a runout here to check what is the content of individual sheets and to get this list box actual updated. Yeah. There is some information about material properties not to be used today because we did a lot on this and I don't recommend. Then there are some further functionalities which are today, I would say, they are obsolete because they have no continuation. But what is very important is this show button. But I do not want to get it corrupted because if I did here the change and because of that it doesn't work correctly in this moment. So I will show you what it does in that moment. What show does is that it will ask you for which group of sets you want to proceed. So you can select what you see here. And if I proceed, for example, to TUC, I can select which curves I want to get shown. And what it produces, it will convert this sheet into something which looks like that. So this information which I have in the data sheet is converted into, I selected maybe not the right one because of it's more complicated than it should be. So I select, there is a lot of information added on. So let's select something else. And here I selected, well, description of all tests in the Fabest, which is a bit quite big, so it takes some time to upload. And what it generates, it generates a file which, based on my request for given curves, will provide me three sheets. First of all, first of them is the sheet description, the CSV file, basically. What I see here, I see that fab is not here in this moment, so I would have to upload it. But what I see here, if I check it, if I try to show, it will be copied completely into this section. Then it produces a sheet which is called sum up, which basically goes through individual curves and writes me here all regression data which I will obtain. Then it does the same for Mason-Coffin curve, so this can be omitted anytime. And then it comes to those individual curves, and this is the most important part, because so based on my input, which is converting to CSV file, it will generate me automatically this description of, no, this is a set of descriptive data related to this SN curve. Then it generates a table with all experimental data which we've got. This is here. Then it generates those functional buttons and this graph, which is in that moment without the content. Maybe I can be simpler to show you. Some specific content. Because the design is too complicated. So let's start. I hope it will work this time. I will create a copy of this TUC file. And I will push reload so that the database is automatically uploaded, plus push show button. I check that I won't work with the TUCC description and put there, for example, 4 first fatigue curves. Oh. That's not common because of the privileges should be still the same. I do not know which problem I generated because of such things should not happen. but usually whenever you want to show something up, it happens. The issue is that when you work with macros in VBA, Visual Basic for applications, it should be accepted, but from to me unknown reason, it doesn't want to get me to this. Here. It's not that I need. I don't know what is wrong. I know, here it is. It seems that Microsoft modified again how the macros can be accessed. This is probably also the reason why I'm getting this annoying bug. It seems that I will not be able to run it today. So sorry for that. Let's go back to that ready-made task. Okay. Not that. So once again, what we see here are individual curves for individual data. When you get it from FinLiv application, there are only data points here. And this is the reason why you have here those functional buttons, because of then you are the one who can run the regression analysis. So the graph is generated, the table is generated. This table is there as well to describe what is the content of power law regression. Yeah, but it's without values. To fill it in, you have to run first the description of the fatigue curve. And here I can try for you, just for information, to show you what is the difference if I select all data points, which I have here, including the runouts here in this right section. These are the experiments which didn't end with the physical crack, and how the curve is deformed, yeah, because of these are much later on. The curve in that moment doesn't follow the central trend around the data, and this is basically erroneous regression analysis. So I have to get it back and push it to just those correct points, because over here there will be some transition of the fatigue curve to the horizontal direction. And something similar can be done with KV curve. This is Kahoot-Wichert curve, dated to 2001, which is very handy because of it allows you to change the trajectory. It's a S-type curve, starting with this plateau to the transition to finite fatigue life, and again to plateau here. So you see that it follows this trend. In some cases it is more visible, in some cases it is less. For example, here you see how it is, how it looks And it's for some cases it's much more reasonable because of simply what I see here. If I apply the ascent curve by power law, that's this one, you see that I have to decide which specimens belong there. In this moment, I have a standard deviation of logarithms in lifetimes 0.18, which is quite nice value, not that bad, yeah. But if I include also these data points, because of they are there, I am getting curve which theoretically fits to all data, but you see that already the standard deviation of logarithms got to say 50% higher value. And it is also visible that very likely the change of the trend is here. So I will again back to the correct representation and say that Kohut-Vihet curve, the KV, is capable of catching this transition much better without any pre-selection of experimental data which should be part of the ascent curve, which should not be part of the ascent curve. So these functional buttons are here for you to prepare everything. This information is then projected. What is this? Is then projected here to this sum up sheet. So here I see what are the regression parameters of the Kohut-Vihet curve. What are the statistical parameters of the regression, plus some dedicated proposal how to evaluate the quality of the experimental data. Plus I see in which lifetimes my model of the fatigue curve is interpolating and in which lifetimes it is extrapolating. Blue color background means that this is interpolated area. So then I can check in which lifetimes I am interpolating for any future task. Once I have this information for all curves, I can push a button write to CSV and get this information back to this CSV, which can be again uploaded to FinLiv interface. So in that way, I can produce technically whatever I need for common ascent curve inputs. What I miss there is something what I'm doing usually manually, and this is adding a graphs file, because over here you see that I'm getting a single graph of all experimental data for this fatigue curve. But if I want to compare something, I'm doing this manually, which is taking too much time. Technically, it should be also programmed as a separate tool for dealing with this. But well, FinLiv is closed task. I do not want to continue in its development. But what I would be very happy just to have a tool which allows me to select which curves I could choose, I could get together to be compared with which representation, if a power law, if a Kohut-Vihet curve, if some other ascent curve description, and how to combine them. Yeah, but for example, if I can modify colors or whatever else. So this is something what is really missing there. I told you that the website representation is not here anymore. We are not working on that, and even if I have to proceed with getting back the database which we prepared, it would take me some time. I would rather prefer to start from scratch in that moment. But what I wanted to say, a lot of experimental data here is already generated. These are all data generated by Show, which allows me to get back to specific experimental setups I would say that I have about, well, maybe 200, 300 such files, which can translate to about 5,000 curves or something, 1,000 to 5,000 curves. I didn't count that. Anyway, once the first project ended so badly that I told you this had to be dissolved and regenerated, we had to prepare a new product which was called Matic, and it was used solely for our own needs. We didn't want to proceed with it further on. We started to hesitate if the way we do it is good enough. In FinLiv, I showed you theoretically for the very start is not bad. The information, the quality of it, which we are gathering, is quite abundant. In many papers, you will not find a feed for that to fill it in. But for example, here, if I check this part about master and slave channels, we can get into serious problems. For example, first, if I have just a SN curve with dedicated values here, it can happen that the machine is not capable to control correctly all inputs. That means, for example, it doesn't reach this predefined value, stays some way below. But in addition to that, for example, the mean value needn't be stable. It needn't be well enough attached to the master channel, to the amplitude. It can happen that, for example, you have a combination of tension and torsion loading, and the ratio between both can differ in some way. So one of the first question is if it is good enough to deal just with those perfect representations, if it is not more correct to write the, say, raw data, information about desired load level, real load level, about any discrepancies between mutual load channels. Yeah, that for example, for some cases, the torsion load didn't reach the expected value but stayed 5% below, for example. So this is a kind of level of detail which is very problematic to deal with. And in this moment, I am rather favoring this ideal representation with potentially some comment that, for example, this data point it's not completely well described because of this error. And then it is up to the man or woman who is working with this representation to decide if to abandon this data point or if to work with that. Second, what we were aware of is that we are missing quite a lot of information. We have here a description of potentially of all SN curves and all Menzon-Coffin curves or static curves derived from some semi-product. But the issue was that, for example, information about the hardness, information about roughness was missing there. So we started to think about how to address this all to make it even better. And this ended in something which looks like that. And I think this was mostly my fault because I was still, even in that time, still in love with Visual Basic and programming in Excel. So I persuaded the guys who helped me with that to continue with the same type of structure partly, but with more information to be gathered. And I think that this was an issue, that a much better solution would be not to persist on the partly readable format. Because of what I was inspired here was simply here with this content. because of when I got into filling in the data, it was much quicker not to work with interface, I mean with this first sheet, but to work with everything directly here. Because of after a short introduction, I knew what the individual abbreviations means. I knew what are the typical values for these items, so it was much more straightforward. And I believe that even if we increase the level of data or the scope of the data, it could go that way. And I do not believe that anymore, because of here you see how complicated the sheet information got. Basically, it uses the same structure, that there is some B column which shows what is the content of the data. There is a descriptor because we wanted to make the processing of the information simpler. So that was a hint for the website representation, and also for the interface, what to expect of to be content of this item. And then there is the value. Again, this is about semi-product. In addition to previous, we have here information about the semi-product type, about unit we use for the description, if there is any photo of the semi-product, and any mentions about preparation, if there was done any metallographic analysis, and we have photos of that, if there are some additional curves which are related to describe basic information for multi-Excel analysis about unnotched, notched information, and so on. What is the type of treatment? Previously, we were limited by at a maximum 4 treatments to be dealt with for a single material. And once we started to digest more data, we have found out in some cases when the description is really good, it can happen that 4 is not enough. So we wanted to make it easier. And you see, because of we noted that it starts to be too complicated, we started, instead of having those individual treatments one after another, we decided to push that into a way that those several treatments are one after another in the same cell, divided by what do you call it in English? A bar, vertical bar. So to isolate individual values for individual subsequent treatments. So more information about environment, about the medium in which was potentially the part, for example, submerged, and so on. Description of treatment series, because of we knew that once there are more experimental data for a data set, it's easier for the person who is trying to aggregate the data to relate just to a typical thermomechanical treatment for some part of specimens, instead of doing again and again the description of the same process. So we generated something which we called types. And here you see that, for example, here there are 4 different types of treatments, which are then described in some way here. Then there is the description of hardness measurements, of roughness measurements, which can be appended to a specific test case. There is much more information about specimen, how it looks. And again, it's separated into groups. What I showed you here, for example, here we have 3 different types of specimens. One is full bars with the same parameters. Then there is a hollow bar with the same parameters, and another hollow bar specimen, but with much higher, bigger cross section. So technically, this can be replaced here, that the person who is aggregating the data will define just one configuration, second configuration, third configuration, and once they are there, I can relate it to any further fatigue curve. The same here, a description of realization, which is omitted in the previous version at all, and it's quite good, not for data which we digest from papers. The information is usually not available, but for future cases, for example, for Fabus, who is the one who tested that? Yeah, at which location it was tested, in which, say, year, and what is also very important type of machine, because of there can be quite a lot of different variations as regards, for example, the quality of centering the specimen in the grips. There can be differences as regards the quality of control of the loading, or at least of recording the data. For example, at CTU, we are using Amsler machine resonator, which is awesome, and we have there also a record of the loading. I know about other universities who have, which have also such machines, but they do not have a record from the loading. So we can reanalyze the content, what was the real load during the time, and it's very dynamical, but other universities cannot do that. Then there was about control of the loading, about the description of potentially any strain gauge measurements or extensometers, and the description of the curve itself, which now relates much more to those series. As I told you, types of specimens are here instead of all specimen data, just a name of the specimen group. The same for description of the treatment and so on. So that was basically the intention. And once we had it, we started to work with web representation also, and with extension to multi-component testing. That means, for example, fatigue in contacts, because of it asks you to put together a description of different parts of the setup, plus the mutual contact. But what I wanted to highlight here, you see that now there is a lot of functionality hidden, or not functionality, but of information hidden in these tables. There is some reference to table material standard, and this is written here to the next sheet, from which it is uploaded, and from which it can be uploaded also to the database, because of it shows you what we predefined as IDs, values of standards, and also a tip box, a hint. The same next, what is the strain analysis? At first, because of when you are running strain life testing, it quite matters if you are going first to tension or to compression, because of it will modify your yield surface. Then, which type of strain analysis technique is used? What are the test groups? Because of a lot of codes today works with classification of materials to specific groups, and for these they propose specific values of constants to be used in prediction. So you see the setup for different materials. Then what are the types of surface hardness measurements? Some are very common, HV, HRB, and so on, but there are very obscure ones in some cases. So again, to describe what is possible, what is the surface roughness measurement type, which parameters we can observe, what types of load channel, no, this is for heating and cooling methods for heat treatment. What is the description of grain size, in which parameters it is it is described, metallography, type of specimens and their description, what the individual parameters are there, where the specimen is located in the semi-product, because of it can matter a lot. Yeah, in our case, in the Fabus, we have a semi-product rod of 35 millimeter diameter, and we know that first up to depth of 15 millimeters or maybe 12 millimeters, it has significantly different hardnesses and hardnesses and also fatigue response than the central core section. So the definition where the specimens were taken from is quite important. Specimen orientation, as I told you previously, how the KT, which is there referred, is provided, was derived. What about the semi-product, how it looks, which type of semi-product it was, because of it also affects the fatigue results. Which type of curve we want to work with, and we should first focus just on SN curves because it is the simplest input. Again, the quality of the input as regards the quality of the data, how we retrieve them, what is the nominal, what is the net stress, or sorry, what is the reference stress we work with, which load channels there are as regards the environment. Then about processing, again environment, which units we use for description, and that's basically all. Type of load regime, similar to the previous case. So these data tables could be an inspiration for us. What is worth to digest? And for me, the issue is in every time how to make it as much as complete and how not to overload the person who is doing the aggregation, how to help him or her. One of the paths is to generate relic classes, as I told you. Yeah, for example, here I know that for U-notch configuration, I have dedicated inputs. The same here, for example. For smooth tensile specimen, I know what are the dimensions, from which position it was obtained from the semi-product, and so on. So I can use this representation and not to repeat it again and again. So to simplify the input of data as much as possible. And that's basically the end point. Yeah, we've got into this position, not bad, but we stopped with the development because of in that moment work with Visual Basic started to be too expensive. It's not a perfect tool, Visual Basic. It is not anymore supported by Microsoft. Already in 2018, it was said that this internal language, programming language of Microsoft products will be exchanged by Python. I do not know what is the status quo now. Visual Basic is still working, but it has very many deficiencies as regards the quality of programming in it. The guy who worked on that with me in that moment asked me, okay, so could we convert it into Python? It's awesome. Yeah. And at last I accepted that, but then we didn't proceed at all. So the question here is, first, you see here we separated the task for data aggregation to a dedicated tool, which is completely standalone, not connected in any way to internet. This is a solution, but I ask myself if everything is running behind on Python. Well, it can be on internet as well. It doesn't have a sense. why to prepare a dedicated tool with a dedicated interface when everything could be input on internet. The question if it is if it is really so well helpful. Yeah, maybe better solution is to have a really standalone application for putting all the data in, then transmitting it to some other member who checks the content. If the same tool says, okay, that seems okay, and in that moment to digest it into the database which is on internet. That could be a solution still working here, but I'm not sure it's worth it. Yeah, basically it is related to our intentions. Anyway, what I liked here is that we are getting some intermediate file which contains all the information. I believe that this way of comma-separated value sheet is not perfect because of in this level of complexity, it doesn't help us. It's not readable anymore. And some XML or JSON or whatever else could work much more effectively, taking into account all the tools which are there to process these types of inputs. So please, now the discussion is open. Yeah, I know that it was very quick, but the question is, for example, for me still Excel is quite mighty tool, though many more my colleagues are already working solely with Python because of it allows them better formatting capability of graphs and so on. But I quite like that as it was.
So maybe Jana, so clearly this has been something that's been in the works for a very, very long time, and there's a lot of development that's been put into this. Um, you don't see this as a base for Faber for continued development. You think this is outdated and there is no requirement to go to
I'm
something
not
that's
saying
new.
that. I'm not saying that. For example, the database structure here, it's quite good point to start with. Yeah. Uh, but I do not like this comma separated value sheets anymore. I don't think they are good. So that should be replaced for sure. The way how we work then with the data, well, technically all the content which I showed you here, it can be replaced with dedicated macros in some other applications because over here it is for getting a representation of the data to look at them, to select which of them should be used for which type of the fatigue curve. Yeah, to get the SM curve representation, and if possible, then to transfer it to some evaluation with other curves from the same set or from other sets. So this can be again done potentially either in a separate application, maybe, or directly on in the website interface. I don't know what is better.
Yeah,
Uh,
something to think about.
yeah,
For me, it was very interesting. It's food for thought and something I want to further think about when we further define the how the database will be developed in working group one. So definitely thank you for the what was a quite accessible
it was
explanation of the data
lengthy. It
set.
was lengthy. I will. It is recorded, so I push the record into our VG1 working group channel on Teams. I will push there also some examples of resulting Excel sheet and also the FinLiv application so that you can find it there. And for me, in Ghent, we should discuss what are the necessary items and how the workflow should look. Really, what is very important for me, for sure, we have to have a database which is on the internet. Should the ingestion and digestion part be a part of the website, or should they be standalone applications?
Yeah.
I'm not sure.
Yeah, probably there are pros and cons for both. Yeah.
What is better? What is better also for continuation of work? Maybe the standalone applications allow us better control between individual versions.
Yeah, I think I discussed quite a lot of this with Jan also with on Jan Viborny during the STSM the last 2 weeks. Um, I feel that based on what we discussed, is that something that's standalone that can be downloaded offline with an online version that's maintained containing the latest data that's curated by a specific core group of people that seems to be the most maintainable. We have looked into various database types and structures, and there are definitely very nice and very well developed frameworks which can be used, but on the other hand, they are quite complex, require a lot of expert knowledge on just the programming side, the maintainability of these things, which in given the resources in Faber doesn't seem really
Yep.
suitable. So that's something we discussed, but I can go further into that maybe Wednesday. Then I'll show a bit about what was discussed, but there we also were at first the idea which I presented last time about a non-structured database. Seems like we're now rather pivoting back to more simple SQLite based database, which will be a lot easier to maintain just because the complexity that's related to the non-structured database and the fact that nobody who is really active in working group one has actually has experience with these non-structured databases. It will not make the process easier, right? So that's why we are saying, and then I think with SQLite, there's a lot of overlap or similarity in the structure compared to what you have just shown here. So
Yeah,
if there's a
everything
lot of
here
things,
was converted into SQL, yeah, so
yeah,
we know that that works.
yeah. So then we can use this as a base to further develop, which should make more sense, I think.
Maybe I would ask Svetlana if she has any comments to this because of she has some experience. She works with total material. Svetlana, are you here with us? Hello? We do not hear you. Nothing, no audio. Okay, Svetlana, we do not hear you at all. No idea what's happening there. Okay, any other comments from others? Well, basically the question is, I can provide FinLiv plus some tutorials to it to members if that can help in any way. Technically, what you see here again, this CSV file, we have prepared already a conversion tool from this CSV file to this CSV file. So technically we decide, let's go with digesting the current data we want to use for different tasks in VG4. It can help because we will have at least a part of data in this structure which can be automatically rebuilt into the new version. The question is if it is worth it, because of a lot of information is missing here, which is sometimes in papers. I have to say that it's not that much. Basically, I would say sometimes there are some additional roughness measurements. Sometimes there is some information about the hardness, but that's basically the most of items which is missing here. For most of experimental inputs, it's good enough. That doesn't mean that it's complete. We should strive for getting better records of the information, but well, it could be worked with that already now. The only issue is that you have to use decimal dot instead of decimal comma, and you have to allow your Excel to work with macros. And the last point is that there are some levels of safeguarding that the macros are not unsafe. So this should be a bit early, say, made milder so that you can run the macro. That's basically all. And also for regression analysis, you need some modifications to tune it up with your Excel version. For different versions, you are using different solvers for nonlinear optimization analysis. So there can be some tiny discrepancies, but it can be tuned. It worked with all Excel files previously until today when I tried. So I wonder what's changed there.
You mentioned that you have converted this also to SQL. It's also included in this, what you were going to share, or?
The issue is that at this moment, because of it was abandoned 4 years ago, I do not know how to access that server and so on.
Okay.
It's a bit funny issue, but I do not have anybody well oriented in these issues, so I'm not sure when I can find uh, somebody to help me to get the data out. But what is of interest for us is that just the database structure. And to prepare it, well, it's not that hard. It's just the description of individual tables in the database in SQL. And
Okay.
more complicated part is are the PHP scripts to work it. It was done in a symphony. That was not already done by me. That was done by some hired staff to whom I do not have any more access. So I'm not sure if it is reasonable to start with that part again. And
Yeah.
tables, as I told you, they are not demanding.
Yeah.
But for sure, we should look for somebody who can help us also with the website interface and so on.
Yeah, definitely.
Okay, other comments, please? If there are no, I'm
Hey,
stopping. Yeah,
hey.
one.
Well, now I'm just trying to catch up with everything, but as I understood, you showed this CSV file, but you have those Feb1, Feb2, Feb3. These are basically all like cards for each card for the database.
These cards, for example, here you see Feb 001.
Yeah.
this is a representation of this column, curve ID 1, and everything what is written here up to the end, that's in this sheet. So everything for this workbook is contained in this single CSV file. That's the most important output of this session. Yeah? We can convert all the information about a complete data set to a single file, which can be read through by further applications. But on the other hand, it's very important to have something with which we can generate these individual sheets, because it helps us to work with the data, to run the regression analysis, to compare different data items.
Okay.
So we need both.
And okay, so essentially CSV is the initial file. Yeah.
Yeah, that's the reason why it is here, because I can also when I get here, when I build this first file by showing it in FinLiv application, I get just CSV, sum up, which is mostly empty in that moment, and all those sheets are without the regression curves. They are just with the data points. So then I go through them, and I will start to run SN curve, then I can run cohort head curve, and so on. And once I have those representations, which are automatically projected here to this sum up, I push right to CSV, and in that moment, it will write the content of the regression analysis here. So once I save it, I can then automatically transfer it whenever else, for example, to Practic Fatigue Solver, and run an automatic analysis on the content of the data.
So, okay, so this is kind of not a database. It's some data are used to generate these files that you use for analysis. It's
a say database suitable just for treating one data set. If you want to compare different data sets, then you will need some external tool or more Excel files that you combine together. The nice point here is that, well, I can add here any further sheets. It will just check that whenever there is a given name related to sum up, it is paired together. So, for example, I created here that graphs sheet. I can generate more information which is related to this data set. I can do any further processing. Well, I'm quite a big fan of using FinLiv because of it's quite useful for my analysis. And what I like the most is that I know what to expect. Yeah? I have a given format which is quite acceptable, and it's much easier to work with that in that moment. So, no more comments?
Well, for now, it's okay.
Okay, so thanks
for comments in future.
Joining today, and I'm stopping recording, and